Okay, so this is question number 9. Again, please pause the video, read it, try to do it on your own. All right, so now is about hypothesis testing, claims, and so forth, right? There is a 5 part, so I'm gonna start one part at a time. I copy here the text, so the reason is I wanna highlight the claim that I'm gonna be using. So here the question starts by a researcher wished to see the average number of sick days a worker takes per year is less than 5. So this is my claim here. All right, this is the claim that I have on the text. So now if I have the claim here, it's saying that the average number, which is the x bar, all right, or the mean, all right, so we're gonna use the mean here, is less than 5. So if I write it down this way, this it can be only h1. Oh, all right, why? Because there is no equal sign. So I don't see any equal sign in here. You see, there is less strictly. They didn't say less or equal, they say less. All right, the 80 is always having an equal sign on it, and according to your hypothesis testing in your book, it would be 80, the mean would be equals to 5. So that's the 80 that you're using. So now because I'm having this in here, this would be my claim. All right, so I hope this is clear. Now if I had to graph it, what I'm going to be graphing, I'm going to be always graphing the claim, which is h1. So this is my normal distribution. Supposedly I didn't read the text yet, but anyway, so this is my normal distribution. I need to define my environment. All right, the 5 is here and the mean is less than 5. It means it would be, this is the tail of separation. This is where you're gonna have your rejection zone. All right, reject 80. This is where you're gonna be rejecting 80. So now let's keep reading. Right, so what they are saying, a random sample of 30 workers, so we know that n equals to 30. That's sampling already. They give you the had a mean of 4.8. all right, had a mean of 4.8. This is actually your x bar. All right, what they gave you here, they give you the x bar, it can be 4.8, and the standard deviation population. All right, so this is very important word. They say standard deviation, but the important word is this one, population. So population, what this mean, population, they are giving you the sigma. The sigma is going to be 1.4. So this is sigma is known. Every time you have sigma is known, you are using the z table. Every time. All right, any time that you have the sigma is known, you're using the z table. All right, is there enough evidence to support the researcher claim at the level of alpha? So this is your alpha. So alpha is going to be 0.05, which is, this would be this area. This is the area of the rejection zone, 0.05. Alpha is going to be 0.05. So of course this one, it can be only one tail. All right, and the tail is going to be a left tail. All right, why the left? Because it's on the left side. Whenever you graph the claim, well, not the claim, whenever you graph h1, whether it's a claim or not, the claim could be h0 or h1, right? So every time you graph h1, it's going to tell you is it on the right side or on the left side. All right, and this one is our k, or our mu0. All right, depend what they are calling it, right? Okay, so this is basically the first question. How do you enter it? I hope you understand it. So here you're going to type in the mean equals to 5. and then in here you're gonna type in the mean less than 5. Of course this one will be the claim, this is not the claim, and you are choosing only one tail, and this is the first part. All right, so all the information are coming from the text, we are not guessing anything. So the next part, is asking you to find the critical value or values. All right, okay, what is the critical value? All right, remember we did this on the axis, we did this one on the axis x. All right, bar in here, x bar. So what does mean x bar? My environment in here. All right, so probably I should make another graph. And again, I'm going really slow here, so I'm trying to explain and do the problem at the same time. So if I'm having, this is x bar, this will be my sigma, no, sorry, it would be the mean, mu 0 is going to be a 5, and sigma x bar is going to be equals to 1.2 divided by radical n, right, which is radical 30. And let me verify the numbers, is sigma 1.4. Okay, not 1 point, so 1.4 here divided by radical 30, and the mean is going to be 5. So this is my environment where I'm working. Now I am having the alpha is going to be 0. So this is 0.05, which is the alpha. This area will define my rejection zone. Right, we define reject. So I am looking for, so I am looking for the critical value. So always whenever you look for the critical value, you are not looking into the x bars chart, you are looking into the normal distribution. So there is a x cutoff here, yes, that's critical value, but you are not working in this environment. All right, so the real environment that you are working, whenever you are looking for the x bar, you are working in this environment. So the environment is completely different. You are working in z environment. So whenever you put z, the mean is going to be 0 and sigma is going to be 1, and this tail, that's the only thing that stays the same. This is the alpha here, so this is the same one, alpha 0.05, it is the same one, and this is going to be z critical value that what we are looking for. All right, so it's very important to know that you are working on the z values, you are not working on the x values. The environment is important here, so do not use the wrong information, right? So now what I need for the environment, of course, I need the alpha, the left side, out the left, all right? You need the environment, and here the calculator will give you this, out the left side. So if I had the right tail, it will be a different story, all right? A right tail, I will have to do completely different story. It's not the same thing. So the calculator will, the function that helps you with the calculator here is, again, you can find it under second and bars, and you go to inverse normal, and you're going to put the area, which is 0.05. Let me double check. So 0.05, yeah, 0.05 is good. All right, so you're going to put 0.05 there. The environment is going to be 0 for the mean. Sigma is going to be 1. All right, you paste it, enter, and that's the value that you're looking for, minus 1.6448. And I think you might wanna round it, round your answer to 2 decimal places. All right, so you're going to be negative 1.64. All right, so they say only 2 decimal places, at least 2 decimal places, so you can put 5 later on. 1.645. All right, so again, remember, is because we have only a left tail, is gonna be only one z critical, only one value, minus 1.645. all right, we are not doing the 2 tails for this question. All right, next. All right, so here, compute the test value. All right, so the test value is given to you. We are working in this environment, so what is the test value? You remember we get the x bar over here. X bar is 4.8. So what you're gonna do, you're gonna calculate the z test. Okay, how do you get the z test? So the z test, you're gonna have to use the formula, which is the x bar minus mu x bar. Let's put it mu only, divided by sigma divided by radical n. All right, so if you plug it in, this is going to be 4.8 minus the 5. All right, and sigma is going to be 1.4 divided by radical 30. Okay, so everything is coming from the information that they gave you here, right? N equals 30, x bar 4.8, sigma 1.4, and you just have to plug it in and calculate it. All right, let's do this. Open a parentheses, 4.8 minus 5 divided by, open a parentheses, again be 1.4 divided by radical 30. Okay, exit there, close the parentheses, and that's going to be negative 0.782. 0.782 negative. All right, so if I plug it in here, this is going to be somewhere here. So this is the z test, and is equal to negative 0.782. So now, how I'm going to make a decision. All right, so the way to make a decision is, again, the z critical is the separation here between a reject zone. This is your reject zone. All right, if you do not reject, it will be the acceptance zone, and this is where happened the z test. So obviously this is do not reject zone. And always we are talking about 80, right? So always our reference is 80 whenever we are doing this. So here the z that we just get negative 0.782, at least 2 decimal places, so it's good. Next, and now we are taking a decision. We say do not reject. Next, so if we did not reject, are we supporting the claim? Actually, we had 80 is opposite to the claim, so we did not support the claim. And the second thing, do we have enough evidence? Every time whenever you do not reject, you don't have enough evidence, right? So if there is not enough evidence to support the claim. So there is not enough evidence to support the claim that the number of sick days is less than 5. And that's basically it. All right, I hope this helped.